This section is on solving linear equations, and so let's define a linear equation at the top of your notes. It says a linear equation in one variable is equivalent to an equation of the form ax plus b equals 0, where a and b are real numbers and a is not 0. And a linear equation is a first degree equation, meaning that the exponent on the variable is an implied 1. There is no squaring or cubing or anything. So you'll see in this box the steps for solving equations, and we will go through these steps as I do a couple of examples, this all being review. So the first one, our first step, it says remove the grouping symbols, meaning distribute. So we have 5x minus 15 plus 9 equals 2x. Now do not write that negative sign. What is being distributed is a negative 3. So negative 3x, now you can write it, and negative 3 times negative 4 is positive 12. At this point, we want to collect like terms or combine like terms on each side, so that gives me 5x minus 6 equals negative 1x plus 12 on the right. I'm going to get my variables. It says isolate the variable. I'm going to get them on the left, so I'm going to add an x to both sides. That gives me 6x minus 6 equals 12. Let's continue this up here. I'm now going to add a 6 to both sides. I get 6x equals 18, and finally I'm going to divide, and that is how I isolate that variable, and I get x equals 3. I can check my answer just by plugging in a 3 in the x spot. I'm not going to take the time to do that because I'm assuming at this point you can do that on your own. Example 2, again we're going to distribute, so that gives us 18 minus 3x equals negative 3 minus 3x. In this case, I am now going to add a 3x to both sides, and you're going to notice when I do, the x's zero out on both sides, and I get 18 equals negative 3. What does that mean? It doesn't mean x is equal to negative 3. It doesn't mean x is equal to 18. It doesn't mean I can divide by negative 3. It means that that is a ridiculous statement that is never true. Therefore, there is no solution. And that is the answer. There is no x that would work and make that a true statement. Another way to say that is the empty set. That is not a 0. That is a symbol for the empty set. Example 3, we have fractions. So the first thing we want to do is get rid of our fractions. You want to put each term in parentheses. This is all one term on this side, and I'm going to multiply by the LCD of my denominators. So I have a 2 and a 4. By the way, I don't know why I did a bracket on one side and a parentheses on the other. A 2 and a 4. So I'm going to rewrite this so you can actually see a little bit better what we have. But I want you to notice that I did not distribute first. I'm going to get rid of my fractions first by multiplying every term by the LCD, which is 4 over 1. So I have to multiply this one by 4 and this by 4. 2 goes into 2 once, it goes into 4 twice. 2 times 1 is 2 times x is 2x minus 20. Those 4's cross cancel, and I have a 3 times an x minus 3. Don't try to get rid of the fraction and distribute all in one step. Now we're going to distribute. So 2x minus 20 equals 3x minus 9. I'm going to get my variables together by subtracting a 2x. I get negative 20 equals x minus 9. Now I'm going to add a 9, and I will get x is equal to negative 11. Again, you can check that answer by putting your x in right here and checking to make sure that it works, and it does in this instance. All right, so that is the first kind of equation. It's just a plain old linear equation, one variable, nothing's been squared, easy to solve, following those steps. Let's look at a rational equation. This again is a review from prior courses. A rational equation in one variable is an equation where one or more of the terms are rational expressions. So we have to be very, very careful here because of what is written here in this second box. The domain of a rational function consists of all real numbers except those that make the denominator equal to 0. Those are called a domain restriction. So we are going to look at one of these, and I will go through these steps with you as I work one. So the first thing that I want to do is I want to find my domain restriction. A domain restriction occurs, in this instance, when you have a variable in a denominator. This is a potential domain restriction area. So I'm going to say, when does x plus 1 equal 0? Because when that is true, then that's the number that I don't want x to be. This is an easy one to solve, and you can see when x is negative 1, this denominator would be 0. So my domain restriction is x cannot be negative 1. So that's the first thing we want to do. Secondly, I want to know what my LCD is because I'm going to multiply both pieces, both terms, all terms of my equation by that LCD to clear the denominators. Well, in this case, I need a 2 and I need an x plus 1. Do not distribute that and multiply it out. So beside this one, I'm going to write 2 times x plus 1. Beside this one, I'm going to write 2 times x plus 1. Here is what happens. The x plus 1's cross cancel, and on this side, I'm left with a 2 times 3x minus 2. On this side, the 2's cross cancel, and I'm left with a 1 times an x plus 1. Let's go ahead now and solve this. We distribute, and we get 6x minus 4 equals x plus 1. I'm going to isolate the variable. 5x minus 4 equals 1. We will continue up here. 5x minus 4 equals 1. Get my numbers on the other side. Divide by 5, and I get x equals 1. Now, the question is x now allowed to be 1? Well, since the domain restriction is x can't be negative 1, it certainly can be 1. And so our solution is x equals 1, or you can write it like this. This is showing it as a set, the set whose member is 1. All right, let's try another one. Once again, as you see here, it's this very similar one. Instead of it equaling 1/2, it equals 1, but it's the same equation. So I know that my domain restriction, I'm going to abbreviate, is that x cannot be negative 1. And I know that because there is a variable in the denominator, and if it were negative 1, I would have a 0 here. My LCD in this case is just x plus 1. I don't have another denominator. So this goes in parentheses, this goes in parentheses. Both sides get multiplied by x plus 1. Those cross cancel. I get 3x minus 2 equals 0. I'm going to solve this one. By the way, it was 0 because 0 times anything is just 0. So 3x equals 2. I divide by 3, and I get x equals 2/3. Is that okay? Yes, because the only thing x could not be was negative 1. Now, should I put this back in and check it? Yes, you should, but I'm not going to take time on the video to do that. All right, let's look at number 6 here. I have variables in the denominator. Now my denominators are the same, so I only have to do this one time. My domain restriction, I think you can tell by inspection, I don't need to set that equal to 0, is that x cannot be 1, because if it is, I would have a 0 in either this denominator or, well, in both denominators. So x can't be 1. Now we're going to go about the business of solving it. And because this is sort of small, I am going to rewrite this like this. My LCD in this case is x minus 1. That's what I need to multiply all terms, including this one, by to clear the fractions. So x minus 1. This cross cancels, and I have 3x plus 2 times x minus 1, I'll distribute that in a minute, equals 3. 3x plus 2x minus 2 equals 3. 5x minus 2 equals 3. I combined like terms. Add a 2 to both sides, and I get 5x equals 5. I divide by the coefficient of the variable, and I get x equals 1. But remember our domain restriction. X cannot be 1, and so my answer is no solution or the empty set, whichever way you prefer to write it. All right, continuing to number 7, let's look at one that's a little more complicated. You can see my denominators are more complicated because they have, the one in the middle has more than one piece to the denominator. So let's first find our domain restriction. This denominator cannot be 0, so x plus 5, if I set that equal to 0 and I solve, I see that x can't be negative 5, because if it was, that would make that a 0. I've already done it here. Let's look here. You can do this one by inspection. Same with this one. Also, x cannot be positive 2. If it was either one of those things, we would end up with zeros in the denominator. Now, I also need to determine my LCD. And the LCD has to be enough to cause every denominator to cross cancel. So I'm going to need an x plus 5 to get this piece and this piece to cross cancel, but I'm going to need an x minus 2 to get these two pieces to cross cancel. So I'm going to rewrite this so that I can get it a little bit larger, and then I will write the LCD beside each one to indicate multiplication. I'm just setting this up now. Each term goes in parentheses or brackets, and now beside each term I'm just going to kind of squeeze in that LCD. So x plus 5, x minus 2. You can stack them, it's okay. X plus 5, x minus 2, x plus 5, x minus 2. Now let's see what happens. X plus 5 cross cancels x plus 5. What's left is negative 3 times x minus 2. These two both cross cancel, so plus 7. X minus 2 cross cancels x minus 2, and I have 4 times x plus 5. Now I'm going to distribute, so minus 3x plus 6 plus 7 equals 4x plus 20. Negative 3x plus 13 equals 4x plus 20. I am now going to add a 3x to both sides. Bring it up here, and I have 13 equals 7x plus 20. I'm going to bring the 20 to the other side. I have 7x equals negative 7. And when I divide by my coefficient, I get x equals negative 1. Let's check that against our domain restriction. Is it allowed to be negative 1? Yes, it is. So my answer is okay. This last one of this type is the most complicated because I can't determine my domain restriction or my LCD until my denominators are factored, so that like the one above it, I can see the parts that make up the denominator, the pieces, the factors. So this is a difference of two squares, x plus 3, x minus 3. This is the same thing, x plus 3, x minus 3, and then this is just x plus 3. So my domain restriction for x plus 3, x cannot equal negative 3. For x minus 3, x can't equal positive 3. So let's write it like this. X cannot equal plus or minus 3. That is my domain restriction. It can't be a positive 3 or a negative 3. So my LCD, remember all parts have to be accounted for in the LCD, is going to be an x plus 3 times an x minus 3. Now, let's look at how we rewrite this. We're going to write 5x over, I'm going to write its denominator in factored form, put it in brackets, write the LCD beside it. Do the same thing for the next term. 15, write its denominator in factored form. Put it in brackets, write the LCD beside it. Last piece, last term, put it in brackets. Its denominator didn't need to be factored. Write the LCD beside it. And now let's cross cancel. X plus 3, x minus 3. So I'm left with a 5x. Same thing here, equals 15. This time only the x plus 3 cross cancels, so I have minus times 2 minus x times x minus 3. Let's distribute. 5x equals 15. Don't write the minus sign yet. Wait till you distribute. Minus 2x plus 6. Let's move over to here. So 5x, let's combine like terms. 15 and 6 is 21. So I have a 21 minus 2x. Let's add a 2x to both sides. I get 7x equals 21. That zeroes out. I divide by 7 and I get x equals 3. But we know from our domain restriction x cannot be positive 3, and that's what we got. I have to discard that, and there is no solution or the empty set again. So if you get an answer that is in your domain restriction, you have to discard that answer. All right, let's look at the bottom of the page where we are solving literal equations. Again, this is review. We're going to solve for the indicated variable. So in PV equals nRT, we want to solve for T. This is a very easy one. There is the indicated variable or the specified variable. So I'm going to divide by nr because that variable had been multiplied by nr. Those make ones, and I end up with T equals PV over NR. That was a very simple one. Here we want to solve for y, and there is the y. So I'm going to subtract a 5x from both sides. That will give me negative 2y equals negative 5x and a positive 4. If you recognize this, this is y equals mx plus b. I'm going to divide each term by negative 2, and I get y equals a negative divided by a negative is a positive. A positive divided by a negative is a negative. And I get y equals 5/2 x minus 2. Last one is a little more difficult because I have a denominator, and just like with all equations with denominators, you have to get rid of it. There's the r, but I first have to get rid of the denominator. So I'm going to multiply both sides by the LCD. Well, the LCD is 1 minus r. So 1 minus r on both sides. So on this side, I have s times 1 minus r. Those cross cancel, equals a. Or s times 1 minus sr equals a. Now I'm solving for r, and I want to keep it positive if I can, so I'm going to add an sr. I know I'm creating an extra step, but I think it will be better in the end. And so I have s, this zeroes out, equals a plus sr. I'm going to subtract an a, and I have s minus a equals sr, and here is what I'm looking for. So all that is left to do is divide by s. I can cross cancel this s. I cannot cross cancel this one because it's part of a unit. And so we get r equals s minus a over s